There are four fundamental forces of nature. There's gravitation. Here's an apple falling from a tree. Gravitation is what everyone is familiar with from childhood on. There is electromagnetism, which is a combination of electricity and magnetism. Both forces, again, are familiar to everyone. The next two are forces that exist only within the atom. We do not experience them directly in our world. They are listed here so that we are aware of them, but we will not be dealing with them in this video. The weak interaction is involved with radioactivity, and the strong interaction with holding the nucleus together. What are some examples where we see gravity in action? Here's a picture of the planets being held in their orbits by the gravitational force of the Sun. This photograph shows the path taken by a basketball. Gravity is constantly acting downward on it from the moment he shoots it until it reaches the ground. Books balanced precariously on a table look ready to fall at any moment. Gravity pulls down on these books and only the desk prevents them from moving. Here's a paraglider falling towards the surface of the earth under the force of gravity, but in a controlled manner due to his paraglider. Now for examples of magnetism. The earth is surrounded by a large magnetic field which helps to protect us from the harmful parts of the sun's radiation, as well as cosmic rays from beyond the sun. Here is a common earthly example of a magnet attracting steel screws to itself. Fridge magnets are very common in many homes as long as the refrigerator contains some steel that will allow the magnets to stick to the surface. Audio and video equipment contain magnets. MRI scanning machines in hospitals rely on strong magnets. Maglev trains based on magnetic levitation are held up by opposing magnetic fields, allowing them to run quickly and smoothly on near frictionless tracks. A dramatic example of electricity is lightning bolts. These high voltage towers show how electricity is transported across the country for use everywhere, in homes, factories, stores, businesses. Here's a less well-known application of electrostatics, in which robots are using electrically charged paint to spray onto a car quickly and accurately. And of course, our cell phones, laptops, and many other items too numerous to enumerate. Let's now consider the word force itself. It is used in so many contexts in English that it can interfere with the scientific meaning of the word. Here are some examples. Force of character, the force of an argument, a force of 20,000 soldiers, may the force be with you. Police force, a force 10 hurricane, and being forced to do something. Now let's see how science defines the word. Force is a push or pull on an object that causes the object to change its state of rest or uniform motion. State of rest means the object is not moving, and uniform motion means the object is moving at constant speed and in a straight line. Our everyday forces are gravity and electromagnetism. Originally, it was thought that electricity and magnetism were two separate forces, but in the 1800s it was shown first experimentally and then by theory that they were interconnected. Electric current in motion could produce magnetism, and moving magnets could produce electricity. While they work together in many applications, we can still see them operate separately in the examples to come. Now, gravity is a force that only pulls, it does not push. We experience this every day, so no example is needed here. The electrical force can push or repel when like charges approach each other, or pull, that is, attract, when opposite charges come together. This clip shows the effect of electrostatic charges, that is, charges that do not move, interacting between balloon and wall. Magnetic poles can also push or pull, that is, attract or repel. Like poles repel, just as like charges do, and opposite poles attract each other, just as opposite charges do. This clip shows ring magnets repelling each other. There is a major misconception that I want to deal with here, and that is that if there is no motion, then no force is acting. For example, here's a book resting on a table. You might think that no forces are acting since nothing is moving. In fact, there are two forces acting each other in opposite directions, but balanced in strength. This picture illustrates the situation. The man is standing on the ground and is being pulled downward by gravity. No problem here. But it says the floor pushes upward on the person. Now, it may be difficult to think that a floor has some innate ability to push like a living thing, and it doesn't, but it reacts in a way that involves electrical force, which I will show here with the book and table. Let's look at the table first and recall that all material is made of atoms and molecules. Let's zoom in on the table and see all the atoms making up its surface. In order to make things more clear, I will zoom in incredibly close and show 3 atoms that represent the surface of the table. The black dot is the nucleus, and the red negative shows that the electrons are all negatively charged. The same is true for the underside of the book. The whole surface is covered with atoms and molecules. We know that when we let the book go, gravity will act on the book to bring it down to the table. When it does, this is what happens. You see the electron clouds get squeezed, but since electrons are all the same charge, the law of electric charges say they will repel each other. The electric force of repulsion is extremely strong compared to gravity, unimaginably so. So it is this force of electric repulsion that keeps the book from falling through the table. Here is a theoretical physicist making the point.
When the electrons come within a very small distance of each other, they begin to repel each other, and that's why things appear to be solid when they are actually not. Now, you may think that I'm sitting on this chair, but actually that's not true. I'm actually hovering over this chair, 10 to the minus 8 centimeters over this chair, because of the electrons of my body are repelling the electrons of this chair.
The same effect occurs in this case, where a person pushes against a wall. If someone says there is no motion because the wall is pushing back with an equal and opposite force, it is better to understand that the electrical forces of repulsion between the electrons on the man's hands and those on the wall's surface are what is preventing movement. Remember when I said that the electrical force was so much stronger than gravity? Well, consider a car sitting on the road. It is being held up by the same electrical forces of repulsion. In fact, all houses, factories, and skyscrapers are similarly prevented from sinking into the ground by the electrical force between the Earth's electrons and the building's electrons. The only true forces of nature, then, that we experience are gravity and electromagnetism, together or separately. Anything else, called force, is labeled that way for convenience, and has a deeper explanation, usually based on electricity. The muscular force is an example. The last idea I want to discuss is the so-called force of friction. It is clearly not a force of its own, but it can be measured and studied like a force, and is very important in everyday applications and in industrial applications. It can involve simple calculations like this, as well as very complex ones. Let's review the 4 kinds of friction one at a time. Static friction occurs only when some push or pull is applied to an object. A typical example occurs when someone tries to push an object. If enough force is applied to overcome the static friction, then the object will start to slide, and the opposing friction is now called sliding friction, also known as kinetic friction. Sliding friction is always less than static friction. I'll explain this later. Rolling friction occurs with round or spherical objects. It is much less than sliding friction. This fact accounts for why ball bearings are used wherever possible in machines. Finally, we have fluid friction that occurs when an object moves through a fluid, such as water or air. Friction is not a real force like gravity or electromagnetism, but rather a resistance to motion. The underlying cause is related to surface irregularities, as shown here. As it says, the hills and valleys between the table and the block will get stuck, creating friction. When surfaces are very smooth, friction is decreased, but you can never get perfectly flat or smooth surfaces. Closer examination will show this up. So, static friction involves the interlocking of the irregularities of surfaces. When an object starts sliding, the contact points on the surfaces do not have time to lock into each other, and the result is fewer contact points, which means less friction. In the case of rolling friction, one or both surfaces get slightly deformed, and this impedes the rolling motion. In fluids, the rubbing of molecules against the sides of a swimmer or airplane provides fluid friction. There are other factors involved in fluids which take us way beyond the scope of this topic, so I will stop here. This ends the video about the major forces in our lives.